this video, we're going to talk about molecular polarity. So the very first thing that I want to show you is your electronegativity trend chart. Now, all this is a periodic table, so it's just showing you how to read the periodic table in terms of electronegativity. Your directions of increasing electronegativity go up and to the right. Fluorine is the most electronegative on the chart, and so anything closer to fluorine is going to be more electronegative. Okay, so let's go ahead and just jump right in. So we're going to talk about bond dipoles, molecular dipoles, polar and nonpolar. We're going to get right into it. So molecular polarity, the very first thing that I want to show you is a CO2. Now I'm just going to go ahead and draw my Lewis structure. If you're struggling with Lewis structures, make sure you check out your video library where you can find video on Lewis structures that might give you a little clarity on what we're trying to do here. So this is my actual Lewis structure. And I want you to notice that my oxygens are going to be pulling in the same direction, or in different directions at the same pace. They are equal, right? So they have the same electronegativity. They pull equally, which means they cancel each other out. What does that mean? That means that CO2 is a non-polar molecule or a non-polar compound. So let's go on to OCS. And the reason I wanted to do this is because it too is a linear shaped Lewis structure. And I'm just going to go ahead and throw my Lewis structure together. Again, if you're struggling, make sure you check out the video library where Lewis structure video is, because basically what we have is the exact same thing, but on the left we have an oxygen, on the right we have a sulfur, and the oxygen is more electronegative than the sulfur. So it's going to pull to the left, and it's a big pull, and then the sulfur is going to pull to the right with a little bit less pull than what oxygen is doing. So they are not pulling equally, and they're not going to cancel each other out. What does that mean? That means that OCS is a polar molecule. Okay, so last quick example, we're going to work with water, H2O. So I'm going to go ahead and draw the Lewis structure for water. Now I want you to understand that these are equally polar, okay? These are equally polar. They're going to pull from the left and pull from the right. Oxygen is more electronegative than hydrogen, but they don't cancel each other out because they don't point in opposite directions. Okay, so what does that mean? That means that we have a polar molecule. They don't cancel each other out. They're pulling in different directions, or in the same direction, not different directions. Generally speaking, molecules that are distorted like this one are also polar. There are some exceptions, and what you saw earlier with the linear molecule with the different outer atoms, that's going to be your exception. It's linear, which means it's not distorted, but most distorted molecules are going to also be polar. If you have questions regarding anything that has to do with molecular polarity, make sure that you're reaching out to your instructor, looking in your video library, and I hope this video has been helpful for you.